Hello everybody, how are you? Welcome to Ask Math Anything. I'm here, that's right. So if any of you are wondering what this is about and what you suddenly landed on YouTube, this is something where people show up once in a while, used to be every day, but now it's every week, to ask random questions about math. And what I try to do is I try to answer random questions about math, sort of randomly, in the sense that I choose questions that I think might be interesting to many people who are learning algebra or geometry. Indeed, I've been gone for a whole week. Indeed, that's what some people are saying. That means that some of you are, I guess, people who were regularly subscribing or watching this particular channel. We used to do this every day. Unfortunately, there were lots and lots of things that started to happen, one of which was that I, in fact, also run the National Math Olympiad training program for the United States. And so I've been quite busy with some of those things. Also, something that some of you know is I also work on something called Novid, which is an app to try to stop the spread of COVID-19. And what I've been trying to do is trying to find ways to let people get back to school in a healthy way. So we've been very busy with all of those things. All right, let's see. What kind of questions do we have here? I see that somebody's asking, does my hair look different? Oh, yes, it does. My hair grew. I need a haircut. That's what happened. All right, what kind of questions do we have today? Let me see what we've got here. Oh, let me plug this in at the same time. What I'm plugging in is our microphone. That makes it so that the microphone doesn't run out of battery. All right. Interesting. So I see that we have a bunch of these different questions which are coming in. What's this? So Daksh Gupta has a question. How many zeros are at the end of 126 factorial minus 125 factorial? I'm curious. Let's find out. So you want to know how many... Whoa, what happened here? How come I can't write? Just a second. It seems like my computer has gotten rusty too. Yes. Just a second. So the computer, unfortunately, has gotten rusty. What happened here? Stylus 10. Oh, that's very interesting. So it looks like the computer stylus doesn't quite work. Here's what I'm going to do. I'll answer some of these questions at the same time while I reboot the computer, which is, as you know, that's the safest way to make a computer start working again. You just turn it off and on again. Just a second. We'll do that. Still not responding. We'll turn it off and on again, and I'll answer your questions at the same time. So as you can see, it says no signal. The reason it says no signal is because there's no signal. But for the first question that was asked, which was what happens when you look at the number of zeros at the end of 126 factorial minus 125 factorial, that one's not bad. The way you think of that is that if I have a number with a whole ton of zeros, and I subtract a number that has less zeros, then the answer has the same number of zeros as the number with less zeros. It's like if I took 50 million minus 300. Oh, it's going to be ending with 2 zeros because of the 300, but that's it. It's just going to have the 2 zeros. All this 50 million is not going to help you at all. So in that case, as we're doing this mentally now, let's do mental math. So we have 126 factorial and 125 factorial. How do you make zeros? You make zeros because 2's multiply with 5's. So for example, I can get a 0 by having a 2 times a 5. Or I can get a 0 by having a 6 times a 15. And that gives you a 0. There are a lot more 2's than there are 5's. So because of that, I just need to go and think, okay, how many 2's and how many 5's? Well, the limiting thing is the 5's. So now I just need to know how many 5's are there in 125 factorial. How do you do this? Well, you say, how many multiples of 5 are there? From 1 to 125, it's just 5, 10, 15, 20. There's 25 of them. So that's it. That's the answer, right? There's 25 5's in 125 factorial. How many people like this? How many people like the idea that 125 factorial has exactly 25 5's inside it? Good? Ooh, not good. The reason it's not good is I also need to worry about what are called powers of 5. And you see, if I have the number 25, that gives me 2 5s. And so I need to now say, how do I deal with the case where I might get extra 5s? Well, you see, the 25 gives you an extra 1. The 50 gives you an extra 1. The 75 gives you an extra 1. Every multiple of 25 gives you an extra 1. And there are 5 multiples of 25. So the answer should be the 25 multiples of 5 plus the 5 extra from the multiples of 25. So it's 25 plus 5, which is 30. How many people like that? How many people like an answer of 30? Well, 30 is not quite good because exactly, as Tiger Lee says, 125 happens to be 5 cubed. That's where you get 3 5s. Oh my gosh, my pen's still not behaving. So it looks like I gave a talk last night and it seems like the pen didn't recharge. That's okay. We're about to switch to a different pen. But meanwhile, I'll say that there's one more extra place you get 5s. That's from the 125. So my answer to your question now is 25 for the multiples of 5 plus 5 for the multiples of 25 plus 1 for the multiple of 125, which if I could add is 31. So I think the answer is 31. I think there are 31 multiples. I think there are 31 zeros at the end of 126 factorial minus 125 factorial. And what we will now do is we will now switch to go and, yes, we will now switch and do the whole thing with a different pen. So just a second. So first we put this across. So now you should be able to see something. Actually, now you're seeing a lot of random setup stuff. So let's go here. This is, by the way, how we record everything. So now you're watching how everything works. This is how we record everything so that we can have it for later. Let's go here. Okay, that's good. Yes. All right. Actually, I've got multiple ways that I can do this. I can also do this in a way where I draw with my fingers. No, I can't. Oh, that shows that something is really funky with my screen. So I think what that means is that the screen's drawing ability has actually just stopped. That's a real shame. This is not a very good way to draw. So this is not a very good way to draw. That's strange. It looks like my entire screen's ability to draw has stopped. Just a second. Well, the good thing is even though the screen's ability to draw has stopped, my ability to draw has not stopped. So we will now use a different solution. So this is called problem solving, right? I have another thing inside my cabinet. I'll be right back. There'll be another way to solve this. Okay. Now let's go with an old-fashioned method. I'll plug one of these guys in. Let's see if this works any better. Or let's see if this actually even works at all. Ooh, this works. Okay, so let's do this. I can go here, and that's the top left. No. Oh, that means that something else happened here. Because if this guy can't write, now I'm really curious what's going on. Just a second. That can't write. That can write. We're going to get out of here. Ah, it worked. I'm not exactly sure what happened, but when in doubt, just try and try again. That's what we'll do. So here we go. Let's not do that one. That looked kind of ugly. But I think we're good. Okay, great. We've solved the problem. Let's keep going. So now we have the ability to draw. And yeah, when in doubt, don't doubt. I think what you just watched is that sometimes various things happen. What happened is something mysterious has happened to my screen. I have no idea why. But we just go solve the problem. All right, more questions. Oh yes, and people said that what we just used was Legendre's formula, right? What we just talked about is I was just talking about what happens if I was doing 125 factorial. And what I just did is I said that the number of 5s is equal to 125 divided by 5. Okay, this is actually the formula. Then I round down. That's what this means. That just means round down. And then you add what happens with 125 divided by the next power of 5, which is 25, round down. And then you add 125 divided by 125. And that's what we added together. And we got an answer which was 25 plus 5 plus 1. And that was 31. Okay, so this all works. Okay, more questions. I'm just adjusting to this new way of writing. Oh, Min Ko says, you think I'm giving a talk at New York Math Circle in 2 weeks? Yes, I am. And so that will be a talk about mathematics and COVID-19. More questions. Oh, Matas Vanagas asks, what is the opposite of infinity? That's a good question. If you ask me, I would say the opposite of infinity is something that's finite. And something that's finite is just any kind of number, like 0, like 1. But these are all finite. So I'd say the opposite thing from infinite is finite. Negative infinity seems reasonable too. Somehow positive infinity is over there and negative infinity is over there. But I'm not really sure what else I'd give as the answer. Oh, this is interesting. Unknown Monkey asks, why are quadratics called quadratics? Well, it's because quad. What does quad mean? Does anyone know what quad means? What do you think of when you think of quad? You think of 2. Oh no. But what about quadratics? So that's no good. I have 4. So in that case, why are quadratics degree 2? I think it's because quadratics are often related to squares or quadrangles. So when you start having areas, there's like squares or rectangles, quadrilaterals. It's not that there are 4 terms. A quadratic, right? If you think about a real quadratic, quadratics look something like this. They look like a times x squared plus b times x plus c. Like that's a quadratic. Or if I wanted to write down some actual numbers, it's like 5x squared minus 2x plus 7. That's a quadratic, only 3 terms. So I think that the reason why they're called quadratics has something to do with that there are 4 sides on a rectangle. I also see that Daksh Gupta has said that for the degree 4 polynomials, it's called a quartic. Okay, more questions. I'm looking at the questions that are coming on our moderator chat as well. So, oh, that's also interesting. Someone said for a quadratic, if you multiply without simplifying, you get 4 terms. That's true. I guess that's kind of nifty. Oh. No. I was going to say that the thing that I drew looks like it's even factorable, but it's not. It's not factorable because it's plus 7. But I got excited because I saw a 5, a 7, and a minus 2. If I had a minus 7, let's make it a minus 7. Why not? It's a minus 7 now. If we, for example, made this into a minus 7, then you can indeed factor this. Like, how does this factor? The way I always think of factoring things is I write like a 5, a minus 2, and a minus 7, and I draw a line. And above this line, I go and think of ways to go and make the numbers multiply together. So, for example, I can make a 7 by multiplying 7 and 1. Remember, it's minus 7. I have to do something later. And I have a 5 and a 1. That looks kind of ugly. Now my undo button is harder to get to. I'm just adjusting to this new way of writing. So I have a 5 and a 1, but I still have a minus sign to take care of. And the way you deal with the minus sign is I want to make a minus 2. So I'll put the minus there. And if I do that, I get minus 7 times 5, which add together to be minus 2. So in that case, I could indeed even say that this thing expands. This thing factors. And the way this factors is, this is equal to 5x minus 7 times x plus 1. So you were saying quad, there's like 4 terms if I actually multiply these out. I get a 5x squared, I get a 5x, I get a minus 7x, and I get a minus 7. Kind of neat. Okay, more questions. What else do we have today? Oh, a geometry question. I'm curious what the answer is. Let's find out. This problem is by Dennis Wang. And Dennis Wang says we've got a triangle. Okay, so the triangle is called ABC, like all triangles. I guess I should draw an ABC first. Do I have any right angles? I don't. So I have an ABC. This is what triangle ABC looks like. You know, a pretty legit triangle. A, B, C. Now if I have triangle ABC, then I have D is the midpoint of BC. Guess we got to put a midpoint somewhere. Midpoint just means the point right in the middle. So here, that's D. Next, we have E is a point on AC. Don't know anything about that. AB and DE are parallel. Oh, now I know more about that. If I want to have a parallel line, then I need to say that there's something going on here. Parallel. Interesting. Parallel, and E is a point on AC. And I've got parallel. The way you write parallel is like this. I apologize that my lines are less straight today, and that's because I'm using a different drawing tablet, so I'm not as used to this. Okay? So now when I have this, what else do I know? AB and DE are parallel, and I have that AD and BE intersect. Oh, there's an intersection. Okay, here's the intersection. BE and AD. And they intersect at point F. This is an F. Next, if AEF has an area of 1, oh, I see that. This area is 1. Now there's a question. If that's area 1, what is the area of ABC? What is the area of the whole thing? Nice question. So the question that's being asked is, what is the area of the entire ABC? What do you think? What's the area of the entire triangle? Let's see. So if I have that as area 1, what else can I say about this particular triangle? Well, there's something important. If these two are parallel, there's something nice that happens. Look, this was halfway. If I had that this was halfway and I run parallel, does anyone know how point E is? This is useful. If I had this at exactly halfway and I run parallel, E is also going to be right in the middle of A and C. Right? This is actually what's called the midline. It's the line that's running through the midpoints parallel to that side. Also halfway. Thank you very much, Ethan Gong. Ethan Gong. So what we have now is that this is halfway in between. Now if this is halfway, how can I start to think about what's going on with this triangle? Now we need to think about similar triangles, right? So here's what we'll say. If this DE is exactly halfway along from here to there, then the DE's length is exactly half of the AB's length. That could be useful. So DE's length is half of that AB. And there's something called similar triangles. If you look at the little triangle in here, and then this other triangle here, they are similar by a flip. So this thing flips over to get that thing. Okay? So these two are similar. But what's the ratio of these two triangles? The important thing is that since this is 1/2 of that, then in terms of the similarity, this length is 1/2 of that length. DF is 1/2 of AF. Okay, that's a really important factor. That's an important fact. So here's how I'll write it. I'll say that if the DF is half of the AF, then I'll say that AF is 2/3 of this whole thing. Here's what I'll write it. I'll write it as like somehow this is 2/3 in green, and this is 1/3. By the way, I'm measuring lengths right now. And it's not that the length really is 2/3, it's like as a fraction of that entire AD, it's like 2/3 of it. And the way I'll encode that is I'll kind of write it like this. 2/3 in quotes, 1/3 in quotes. Okay? So what I mean is that this is 2/3 of the whole length, this is 1/3 of the whole length. Why is that useful? Now here's how I figure it out. I'm curious what fraction of the entire area is this piece. And here's what I'm going to do to figure that out. The first thing is I'll say, does anyone know what fraction of the entire area is ADC? Let's write down a bunch of things, okay? So if I'm curious about triangle ADC, I can say that the area of ADC is some fraction of the area of ABC. Does anyone know what fraction? Half! Exactly! It's because D is halfway. So if I look at ADC, if I use the half base times height, both ADC and ADB have the same height. The height is this thing. They have the same height. Oh, and their bases are the same length. So since their bases are the same length and they have the same height, that means that the area of ADC is going to be the same as the area of ADB. Two areas which are the same, so this one is half of the entire area. So that's the first piece. So now if I know that, let's keep going. Well, I want to say this area ADC, I wonder what ADE is, that area of ADE is as a fraction of ADC. Next thing I want to write is the area of ADE is what fraction of the area of ADC. Anyone know? Also half. The reason it's also half is because you see this ADE, and this CDE, they are both triangles with the same height. This is a height. And their bases are CE and AE. Their bases are the same length. So since I have two triangles with the same length base, with the exact same height, they have the same area. And since the ADE has the same area as the CDE, that means that the ADE has half the area of the whole ADC. So I get half. Why is this exciting? This is exciting because ADE is half of ADC, which is half of ABC. So I now know that ADE is a quarter of ABC. I wonder if I have enough space. So this is 1/4 of the area of ABC. Now we're almost done, because now we just need to know what is then the ratio, what is the area of AFE, this AFE, compared to the ADE. This is where this 2/3 is really useful. If I want to know what's the area of AFE compared to the whole ADE, well, if I think of it, they both have the same height, and one of the bases is only 2/3 of the other one. So in that case, the area of triangle AFE is what fraction of the area of triangle ADE? Let me try to write it here. So now I know that the area of AFE is some fraction of the area of ADE, and the fraction 2/3. That's right, 2/3. I saw someone write 4/9. 4/9 would be if I had to square it. 4/9 would be if somehow I squished each side by 2/3. But here I only squished the base by 2/3 and kept the same height. And if that happens, you squish the base only, then only the base goes down by 2/3. It goes down to 2/3. It's half base times height for the area of a triangle. So that's just 2/3 of the entire area. Oh, and the entire thing was 1/4 of the area of ABC, right? ADE, ADE, and that's 1/4 of ABC. So that means that if I can squeeze it in over here, I multiply 2/3 by 1/4, and I get 1/6 area of area ABC. Aha! So now I'm done. Well, I'm done because I've just found out that the area of this little blue thing that I picked, the blue area, is 1/6 of the whole area. And the blue area is 1. So the answer is 6. And somebody in this chat had already said that the answer is 6. You were right. This is how you'd figure out that this particular area is 1/6 of the whole thing, and so the whole area is 6. Let's just write that down. So what I have here is that this area is 1, so then this area, which is blocked by my head, this area is 6. And I'm getting the hang of this new way of writing. Yay! Okay, more questions. What else are you curious about today? Ethan Sao says, I started your modules. They are awesome. Very happy you like them. What else do we have here? I see that Andrew DeFord asked, how do you factor with the quadratic formula? You actually can. The way you could factor with the quadratic formula is easier if the thing you're factoring, right, if the thing that you're factoring happens to have just x squared on its own. So if you want to factor using the quadratic formula, here's something you can do. Suppose that I want to factor x squared minus 3x plus 5. That won't factor very well. Okay? How do I do this? Well, the way you do this is you go and say, let's go and find out what the solutions are. So the quadratic formula is going to give me that the solutions are x equals 3 plus or minus the square root. Help me if I get this wrong. Oh, that's ugly. 3 plus or minus, wow, this is harder to write with this tablet. But plus or minus the square root of 3 squared, which is 9, minus 4 times, oh no, why did I pick these numbers? Ouch! Bad things are about to happen. So 4 times 5 is 20. So then what happens? I then have to divide by 2, right? So I get some horrible, horrible thing happening. So what just happened? I'm getting 3 plus or minus I, that's the square root of minus 1, times the square root of 11, all over 2. Ouch! Ouch! Imaginary numbers showed up. But these are the roots for x. So boom! Now here's how you factor it. You just go over here and you say, well, the factorization is, of course, x minus 3 plus I square root of 11 all over 2, and x plus, oh, not plus, x minus 3 minus I times the square root of 11 all over 2. Yes, that's how you factor this using the quadratic formula. Yeah, and it works. In fact, if you try to multiply this together, you see something nice that happens. If you try to multiply these together, hey, I see the x squared term, x times x, that's the x squared term. Do you see the minus 3x term? You should. The minus 3x term is from, the minus is because there's minuses everywhere, but the 3x is because I have 3 plus I root 11 over 2x, and I have a 3 minus I root 11 over 2x. And if you try adding together this 3 plus something and this 3 minus the same thing over 2, the answer is just 3 plus 3 over 2, which is 3 with minus signs. So that's that. And how do you get this 5? The way you get this 5 is by multiplying this and this. And if you do so, it should be 5. It's what's called a difference of squares. Wait, is that true? Let's find out. It's called a difference of squares. So what would happen? Let me just check the last term, right? So what's the last term? The last term, if I multiply everything out, I hope I'll get 5, but I'm really going to multiply this thing and this thing together. Look what happens. If I took 3 plus I times square root of 11, let's write the 1 a bit farther from the square root, all over 2, multiplied by 3 minus I square root of 11, all over 2. If you try to multiply this just to double check, what we get is what's called a difference of squares, 9, and then minus, well, you minus the I root 11 squared. Oh, what's that? I root 11 squared. And that's over 4. Oh, it's good. I like this. So when you square I root 11, the minus becomes plus, because I squared is minus 1 over 4. That's 20 over 4, which is 5. Hooray! It works! So in that case, we are able to do this too, and I'm just showing that if you multiply these out, you get that thing there. So you can indeed actually factor anything you want just using the quadratic formula instead. Okay, more questions. What other questions do we have today? Oh, Harry Liu. I'm curious what the answer is to this question. Looks interesting. So what you said is that you've got two numbers. You have a number AB. It's in base 7. And it happens to be equal to the number BA in base 9. That's exciting. And you're asking, what's the real number? Like, what's the number in base 10? What is it? Well, what do you mean by what is it? Oh, yeah. What is this number in base 10? So this is equal to what in base 10? Well, here's what we have to do to figure it out. We have to go and think about what base 7 means. Base 7 means I have a B, and I have A7s. That was bad English. I don't mean that we have A7. I want that there are A7s. And what that means is A is a number, and there's like, that's how many 7s we have. So if you ever hear someone say A7s, What that means is that there are a 7s. Okay, so if I add these together, I would get that the left side. What's the left side here? The left side is just going to be 7a plus b. And the right-hand side, there's an a, and I mean, there's a1s, and there's b9s, right? So what I have is that I have 9b plus a. So now I need to go and solve this. I guess I should put stuff onto each side. I then find out that 6a is equal to 8b, cute. So then 3a is equal to 4b. Now if that's true, what could I say? I could say that both a and b are 0. But that's kind of silly. You can't do that. You can't say that a and b are both 0, because if a and b are both 0, you don't write your number as 0, 0. So they're not 0. What else could they be? Well, I could have that a is 4 and b is 3, right? But it looks like I've got a bunch of choices. I've got a bunch of choices, right? So from here, I've got some possibilities. I could have a equals 0, b equals 0, but no, that's like numbers like 0, 0, not okay, right? 0, 0 is not okay. The next thing is, what if I had a equals 4 and b equals 3? That's one way that I could have 3a equals 4b. That seems interesting, seems possible. Oh, but there's more. What if I had a equals 8? b equals 6. That's also okay. Why is this, like, what if I had this? I could have like 8, 6 in base 7. What is 8, 6 in base 7? There's no 8 in base 7. You can't have 8. That's how you rule this out. You see, too big, because the biggest digit in base 7 is 6. Illegal. Dakshgupta says illegal. That's an interesting way to put it. So this thing here, okay, we call it illegal. It's illegal. Too big, right? So that's a no. So then that's telling you need to have a is 4 and b is 3. And if a is 4 and b is 3, let's go figure out what these are. 7 times 4 plus 3. 28 plus 3 is 31. And it should work the other way. 9 times 3 is 27. 27 plus 4 is 31. And so no matter how you look at it, this thing gives you 31 in base 10. And that happens to be the answer. Okay, so that happens to be the answer. 31. Hey, that's familiar. You know, we had 31 as the answer to another problem today. What's the chance of that? 31 was the answer to the how many zeros does 125 and 125 factorial end in. 31 appeared twice. More questions. Ethan Gung has a riddle. The riddle is, turn me on my side and I am everything. What is this? So let me write this down because always the words are very important. So Ethan Gung says, turn me on my side and I am everything. But it says, cut me in half and I'm nothing. Okay, what is this? Oh, nice! This is good. I would never have thought of this. You guys are great. Why are there so many smart people on this channel? Okay. Nice. I like it. I like it. You guys are really clever. So yes, turn on the side, you get infinity, cut it in half, and you get 0. Wonderful. Thanks, guys. More questions. FF688 has asked, is it possible for a line to be made of only irrational points? I'm not entirely sure what you mean by that question. You know, I could make a line. I could make a line with a lot of irrational points, like all irrational points, by making a horizontal line. So I'm not sure what you mean. Like if I was going to make a line, let me try to make some chart. Ooh, it's so hard to draw straight lines with this different way of doing things. Go here, right? If I've got this and I've got this, pretend that those are straight. If I wanted to go and make like a straight line going across here, and this straight line happens to be all points of the form x comma square root of 2, Now this particular straight line, all the points are irrational. But now if you're going to ask, well, what if I want all of them to be irrational and irrational? Now that's not possible. The reason that's not possible is because the line is going to move somewhere, and the x-coordinate will eventually touch a rational number. So, like Harry Liu, you're asking different irrational numbers. Well, that's not possible, because if I want two different irrational numbers, if my line is not horizontal, so like horizontal is the only line where there's only one number there on the y-coordinate. Vertical is the only kind of line where there's only one number on the x-coordinate. But if you're going to be something else, or sorry, not if you're going to be something else, as soon as you have more than one possible value for the y-coordinate, or even for the x-coordinate in this picture, you will sweep through a rational point, because the rational numbers are everywhere. There's a word for this. This is actually called dense. The rational numbers are dense. But the way to think of it is, if I have some rational numbers and I have to go between them, even if I have some irrational numbers and I have to go between them, I'm going to pass through a rational number on the way. Okay, more questions. Oh, FF688 said, I meant to say a line with slope not 1, not 0, or undefined. Oh, that's interesting. Now I want to know the answer. Okay, let me think about this. So, the question now is it possible for a line to have all points irrational? Irrational just means like at least one of the coordinates is irrational. If slope is not 0, 1, or undefined. Undefined means vertical. So my hunch is yes. My hunch is yes. And the reason my hunch is yes is because there's like so many irrational numbers. So now let me go and try to figure out if we could show this. So I want to make a line which has no rational numbers at all. Yes. Yes. No. I'm thinking. So the way I'm thinking is I'm saying, how many lines are there that use any rational numbers at all? No, it's not that simple. Well, I could have like 1 point. Oh, yeah. So the way I'm thinking about this, so people here are already getting some answers. You're getting some answers which are quite good. I'm trying to give an answer which is based on counting. Actually, the way I'm looking at this is I'm like, the number of lines that contain at least 2 rational points is actually what's called countable. The number of such lines is countable. Countable means that I could list them, like here's the first one, here's the second one, here's the third one. And that's because if I grabbed any 2 rational points and I drew a line through them, that would be a way of making it. I'm basically using a counting argument. And what I'm saying is that, there's like too many lines you could make in the world, and the number of them that could be rational is not, you don't have enough of those. The place where my argument isn't completely done is that, it could be that every line has just one rational point on it, but that's extremely unlikely. So at this point, that's making me say, now we should just construct one, right? And I'm showing you the intuition. The intuition is like, there are too many different lines in the world, and there are so many different lines in the world that if I just write down something sufficiently weirdo, it should work. So now let's write down something really weird. And, pi is a great choice. The way I'll write down my line is I'll say my line is square root of 2 x plus pi y equals 0. Okay? And the reason I chose these weird numbers is because they're like not very good for getting rational numbers. So now when you write this thing, it's actually even easier. Oh boy, it's a lot easier. I don't even need the pi. It's great. It's good. Just do the square root 2. Oh, I can do it even easier. Once I see this example, I'm like, no. Life got easier. Forget it. I can just do y equals square root of 2 times x. I claim there's no rational points on this at all. And why? Let's suppose there's a rational number, right? Let's suppose that there's a rational number solution. So what if it's possible? What if I've got rational numbers like a over b and c over d runs into my head? What if this is on the line? Well, if I have this thing which is on the line, I guess I could put them in, right? That's the x, a over b. And then y, oh no, what about 0, 0? That's annoying, very annoying. So now let's go and add some stuff. You ruined my game. So I don't want a 0, 0, that's no fun. So in that case, I need to go and move this a little bit. Now I have to work harder. So I guess if I didn't want 0, 0, oh no. Now how do I go and prove this doesn't happen? I would do something like this, I think. Would that do my thing for me? So now I have this. But now unfortunately, well, it's not that bad. I can write this. I could do plus pi, but I actually want something else that's more weird. Sorry, not as weird, so that it's easier for me to prove something about. So if I happen to have the square root 3 here, what could I do? So if I wrote square root 3 here, let's indeed do this one properly. What if I've got this point on the line? I think this will be enough for me to do. So I'm going to go and write down that y is c over d, I'll stick that there. The x is a over b, I'll stick that there, and let's just go and write down the equation. Okay? So if I write that, that's going to give me an equation which looks like c over d is equal to square root of 2 times a over b plus the square root of 3. Now I'm going to go and copy that onto the next screen and do some multiplying of stuff. And I'm pretty sure this will be enough. So what I'll do is I'll write c over d equals square root of 2 times a over b plus the square root of 3. Now let's multiply by both d and b. So now I have that c is equal to, no it's not, it's bc is equal to ad times the square root of 2 plus bd times the square root of 3. But it turns out that there's in fact no way to take integer, to combine like an integer multiple of root 2 and an integer multiple of root 3 to make an integer. So this is bad. Bad unless AD is equal to 0 and BD is equal to 0. Something funny happened. No, I think it's okay. Right? So it's only bad. So when I say bad, I'm like, the only way that I could make this happen, is if I had 0 times root 2 plus 0 times root 3 equals 0. Because root 2 and root 3 are very different. I'm going to go and prove that in a moment, by the way. But I'm also double checking that I multiplied right. I think I multiplied right. Okay, that's fine. And the reason I say is like, well, what if this is 0 and that's 0? Well, could I have that? Could I have that AD is 0? The only way to have AD to be 0 is if A is 0 or D is 0. But I can't do divide by 0, so I can't do D is 0. So that's not possible. So this thing here would only happen if A was 0. Oh, but then if A is 0, then like root 3 is rational, which is not okay. So I'm just saying this thing is the possibility, but won't happen. But won't happen. That's what we just discussed. So now we know that that won't happen. Now we just go and say why this thing doesn't happen, right? So the way to think of this is, can you write integer equals integer times root 2 plus integer times root 3? Well, no. And the nice way to know why you can't do that is like this. Why can't you write something like e equals f root 2 plus g root 3, where you have integers for e, f, and g? Well, you could just try to square both sides and see what happens. If you squared both sides, you would have then e squared, this is not the 2.718e, this is just like some integer e, equals, it turns out to be 2f squared plus 2fg square root of 6 plus 3g squared. And now you have a problem, because the problem is that you can now write square root of 6 as a fraction. Square root of 6 is e squared minus 2f squared minus 3g squared divided by 2fg, which is rational. And the same kind of proof that shows that square root 2 is not rational shows you that this is a problem. Square root 6 is also not rational. So what I just did is I just talked through all of these things. This is how you can show that this particular line that we came up with, the line being y equals root 2x plus root 3 is not okay. Okay, more questions. Use 3 s's to make 10. Not really sure what that means. Let's continue. Other questions. XOXO, a study asks, trivia question. Which countries share the longest international border? Does anyone know? Which countries share the longest international border? I would guess like Russia and something would be my guess. US and Canada, is that true? I don't even know. I would be like, is it Russia and China? Not Russia and European stuff, that wouldn't work. But then again, maybe it is US and Canada. That's a pretty long border. Oh wait, what about Argentina and Chile? How long is that one? I don't know. So I don't know the answer. It looks like Temp ID says USA and Canada. Maybe that's the answer. By the way, if XOXO a study would like to tell us what is the answer, I'm curious what the answer is. Yeah, interesting. And Ron Yoder says Argentina and Chile are super long in their borders. This vertical thing, it's a very, very, very long. But if I'm thinking about it, I don't really know. US and Canada is correct, says XOXO a study. Good job, guys. All right. Oh, Paulo is saying greetings from Brazil. So you would be the expert of South American geography here. Oh, Unknown Monkey, that's right. Russia and China border is small because of Mongolia. Well said. Okay, more questions. That is stupid is a username. And that person has asked, remember where you talked about the Euler's identity in the Carnegie Mellon University? Please explain how it works, please. I would just say go look on YouTube. You'll find some explanation where I give. It's like a 2-hour thing which talks about this Euler's formula and why it works. Go there. Okay, more questions. Oh, let's try this. Mithun Goswami has asked, how many 4-digit numbers, with the 2 middle digits being 7 and 9, how many 4-digit numbers where you have a 7 and a 9 as the 2 middle digits, 4-digit numbers? It's asking how many are divisible, let's use the full word, divisible by 45 was the question. How many are divisible by 45? Oh, at first you look at this and you say, oh my goodness, 45, what a weird number, this has got to be hard. And then you say, wait, maybe there's a chance I can do this. 45. Oh, Min Ko is thinking, how should we write that? Is there a symbol for that? I don't think I'll use the vertical bar, so I'm not really sure. But you see, so Sophia says it must end in 5. Almost. Not exactly, not just 5. There's 2 ways it can end. 5 times 9, but that's good. Anna Howe is saying that this is 5 times 9. That's important. That's 5 times 9, so it has to be divisible by both 5 and 9. But that's right, the last digit is either 5 or 0. So let's go and try one of them, okay? So what's one of the possible last digits? One of the possible last digits is 0. If I have a 0, how do I make the whole thing be divisible by 9? Well, the way you get the 9 rule, yes, A.S. Guy says the way you get the 9 rule is you add up all the digits and you see whether the sum is divisible by 9. The 9 won't help, the 0 won't help, but the 7 plus 2 makes 9. So if this was 2, I'd have 2 plus 7 makes 9, then I have another 9, then I have a 0. That's how it works. So if I have a 0, then this thing could be 2. That's one possibility. The other possibility is 7, 9, got this, and this guy is a 5. So how do we do this? The way you do this is you go and say, if I care about adding up all of the digits to see if it's multiple of 9, I can ignore the 9s, because adding a 9 or not adding a 9 won't affect whether the sum is a multiple of 9. So I have a 7 and a 5. How do I make these add up to a multiple of 9 with a 7 and a 5? 7 plus 5 is 12, and 12 plus 6 is 18. And in fact, that's the only option. So I think the answer then is there's 2 of them. These are the 2 numbers which are divisible by 45. Thanks. Thanks for the nice question. Oh, 3? Did I miss one? I'm not sure if there's another one that I missed. But I think this is good. I think we're good here. 987. 8970. Oh, I misunderstood the question. Thank you. So in fact, the question didn't say the middle two digits are 7 followed by 9. The question said how many 4-digit numbers have the middle digits being 7 and 9. Well, if they could be 7 and 9 in some order, I could also flip the orders. Is that okay? So I could also have 2970. I could have 6975. So all of these are okay. So the answer is 4. So let's just go and write that down. It's always important to read the question carefully. So we have here, or flip, middle. Okay, nice question. What other questions do we have today? Zero-sum game asked, why is the minimum of x to the power x 1 over e? This is best explained with calculus, but unfortunately calculus is beyond the scope of this particular live stream. But you do what's called taking the derivative of x to the power x. Actually, not really. You rewrite x to the power x as, I'll just do this real quick. I won't actually do the derivative, but the secret is you rewrite x to the power x as e to the power x times the natural log of x. And then, up here, you minimize this. Okay? My handwriting is getting a little bit better through the course of today's live stream. More questions. Calculus says that is stupid. Oh no, 8970 is incorrect. But I see, you're discussing with other people. But thanks for having a discussion amongst yourselves. That's another way to learn. No, we're keeping out of the calculus zone. There's no calculus. You see, no calculus appeared. Only E's and LN's. Okay, more questions. Sophia, you asked, can you give an example of an undefinable real number? Did you just ask me to define an undefinable real number? That's difficult, right? So I think that as if I could give you the example of a number that can't be defined, I would sort of have a problem of circular logic. So I actually can't. Dakshgupta, we got to be careful. Undefinable numbers can totally be real. So there's something that blows your mind, that should blow your mind. There are more real numbers than you could ever express. What do I mean by express? Here's how I can express a number to you. The square root of 2. Here's another number. The number that's halfway between the square root of 2 and the square root of 70. By the way, as I'm expressing them to you, I'm saying words in the language called English, and my sentences stop. So if I express a number to you, I start talking, and at some point I stop talking, and I've said like a finite length sentence where I could even imagine typing that sentence. Well, here's something really interesting. The number of finite length typable sentences is smaller than the number of real numbers. And this is something that you'll learn whenever you learn how to count infinities. They are actually different types of infinities. So the deal is, if you imagined all of the numbers that you could ever have any hope of writing down as like something and stopping, that's not all the real numbers. There's more. And that's kind of mind-blowing. So that means that there are clearly some numbers out there that are just not expressible. Okay, more questions. That is stupid asks, what about defining it as undefinable? The problem is that there's actually infinitely many numbers out there that are real numbers but are not definable. So you can't just be like, well, you know, I've got all these like normal real numbers and I've got that other one there that you can't define. There's infinitely many of them, so you can't do that. More questions. Somebody just gave me a tongue twister. I'm not sure I can do that one because I also don't see the math problem inside it, so I'll pass on that one. Meanwhile, I'm seeing that a bunch of people are talking about these various kinds of like different ways. I'm looking back on the chat, and there were all these different ways of making those lines that had no rational points on them. Oh, here's a fun problem about math, I guess. I mean, about mathematicians. This is by Daksh Gupta. I am a famous mathematician. If you change a letter in my last name, you might be able to measure how tall you are. Who am I? A famous mathematician. Changing a letter in the last name, and you'll find out how tall you are. Oh, you guys are great. You see, that's great. Whenever I have like close to 200 people watching something like this, if there's a question that I don't know the answer, I just read the question, and then all these people give the answer. Euler. Because Euler is a famous mathematician, and if you change the E at the beginning to an R, I guess you get a ruler. How did you guys all figure it out that fast? That's what I don't understand. Because when I was just reading and talking, I was like, I don't know. Let's see. Oh, what's this? Ethan's how? Minecraft Po goes mining for diamonds. He finds 21 cobblestone, 1 diamond, and 1,008,945 coal. What percent of the stuff he found is cobblestone? So this looks like you've got 21 cobblestone and 1 million and stuff coal. So if I look at it, I'm like 21 versus 1 million plus. If you round to the nearest percent, it's going to go to 0%. So I would say it's probably 0% rounded to the nearest whole percent. That would be my guess. Unless there's some kind of a trick in this question. Skylar Shre, bruh, the inventory is too full for that. Ah, I see. So I guess it wouldn't quite fit. Let's see. More questions. Ah, this is neat. Diane Hassan asks, which field in mathematics will grow the most in coming times? I'm not sure. I think that all of the different fields of mathematics are always growing, and it just depends on whether or not you and other people decide to help grow it. They're all different. Like sometimes people are trying to understand more about number theory, and there have been a lot of breakthroughs there. But people are also trying to understand more about how fluid flows, and that's related to something called differential equations and calculus, and people are making progress there. Some people like me think about networks, that's called graph theory, and there's progress there. So actually all of these different areas of math, there's always different kinds of progress going on. I wouldn't go and say there's one particular branch which is the most exciting. Instead, you should sort of try to do as much as you can, learn as much of it as you can. It's all rich, it all works together. And that's why the way we do Ask Math Anything is you'll get random questions about number theory with some combinatorics, and then some algebra, all on the same slide. Especially, this one even has some calculus, which I didn't even talk to you about. But all of these are on the same screen, and it's all related. So don't go and say it's this versus that. It's all math. And calculus, says Minko. Oh wow, William Chen. Is there trigonometry for shapes with more angles than 3? So trigonometry is actually the study of things that are in triangles. So trigonometry starts with TRI. But there's a lot of other things that you can do. So it turns out that trigonometry is really useful because if you want to build any structure, you can sort of build it out of triangles. Triangles are very rigid. If I just got 3 sticks and I just glue together the ends, you can't really twist or bend it to make anything else. 3 rigid sticks. So that's why triangles are good building blocks. But there is in fact something called spherical trigonometry, when you have on the surface of a ball a triangle. And that's an entire subject of math that used to be taught in schools about 100 years ago, but isn't anymore. If you're curious, just search for spherical trigonometry. Oh, let's go and finish up with a few of these general questions. Right. So Diane Hassan says, how long are you going to do math? How long are you going to do live streams? Well, as long as I can. As you can see, I do care about you guys. I care about your audience. And so I wanted to make sure there was a chance to see you guys. So I came and did this today. We'll see. My life is always strange. I don't know what's going to happen next. Anonymous Cheetah asks, how is MOP? It's great. We're just running this Math Olympiad summer program here in the US, except that we're running everything online, where we use these kinds of video methods to talk. It's actually working, which is kind of surprising. Well, maybe not. It's not surprising for you guys, because you've been in this world for so long now. Great. And, Waffle Straw asks, are there any conditions to join the math team that I run? Yes, if you'd like to join the US Math Olympiad team, it's by participating in the American math competitions. That's run by the Mathematical Association of America. So you take what's called the AMC 10 and AMC 12. And as you do these contests, you go up and up and up and up. And at some point, if you go up into the national training camp level, that's the camp we were talking about just now. All right. Well, in that case, that finishes the live stream for this week. Thank you very much to everyone for coming in and joining our community again. It's a real pleasure to see you all. I unfortunately will not be able to do another one until next Friday, but we'll be back at the same time. And hopefully the equipment will work a little bit better next time. Until then, stay healthy, stay safe, and have a good week. See you.